Okay, so now we're going to do the same kind of thing with logarithmic functions. Okay, the basic logarithm graph, and they don't change a lot based on what the base is. The basic shape, the fundamentals, domain and range, they're the same thing. In fact, even though the x-intercept is the same. All right, we know that we have an asymptote here. We have the x-intercept here. And the shape of the graph looks like that. Okay. The domain is x greater than 0, right? It never touches the y-axis, so it's never equal to 0, but it's greater than. What is the range? All real numbers. Okay, I'm gonna graph that in a second. Not one of these, just to show you in a second, but not right now. Okay, let's try the blue one. Okay, what's the shift going on here? -2 inside means right 2. Does that move the asymptote? Yeah, you take a vertical line, you roll the whole thing to the right, it's going to move a vertical line here. Right? It's going to take our x-intercept and move it here. And so the new graph looks like that. Now, if I put that in the calculator, notice what happens. Clear. So it's going to be log base 6 of x minus 2. Math base 6 parentheses x minus 2 and zoom 6. Now, you see what that looks like? The calculator makes it look like it stops there. It does not stop there. Right? It's becoming so vertical that the calculator doesn't resolve it. But if you put that on your test, it makes me think you really don't know the function. You're just copying the screen. And you haven't figured out this approaches x equals 2 like an asymptote. And it goes on forever down. It does not stop there. That's just the calculator. And even this here, you might look at it and think that, that doesn't look like all real numbers. It looks like it's leveling off. Like maybe there's an asymptote there, but there's not. It does go infinitely up. So don't let the calculator graph fool you. It can fool you. Now, I'll get that as the graph, guaranteed by somebody. But remember, that's just the calculator. We know what it looks like. It looks like that. Okay, purple. Okay, what's the shift going on in this one? +3. That's an up 3. When they don't put the parentheses there, it can be a little confusing, but, if they mean that 3 to be in there, they should have it in parentheses. Otherwise, you assume it's afterwards. So that's an up 3. So that's take this graph, the black graph, move it up 3. So does that change the asymptote? No. So let's take this point up because it's the only point we know, and just sketch ourselves a new graph. Something like that. And how about the last one? What else is going on? The -2 means right 2, up 3. So right 2, we already moved the asymptote for that, up 3. So right 2, up 3, sketch.